So in this problem, we're told that a block of mass m is connected to two springs that are in series, one with spring constant k1 and the other with spring constant k2. And we're asked what the period of oscillation of this block is going to be if we displace it from its initial position. We're going to define that initial position to be 0 along the x-axis. So what that means is that the block's x-coordinate is going to be exactly its displacement. And so now we're going to need to figure out how to combine these two springs in such a way that we can figure out what the force is as a function of displacement. Now some of you may already know how to do this. There is a relatively simple formula that you can easily derive or remember about these, how to deal with springs in series. I'm just going to quickly derive it here for those of you who may not remember how to do that. So if the block is displaced at distance x, it has to experience some force from the spring k2. But that force from the spring k2 has to also be applied to the left on the other side of the spring, onto the spring k1. Now that means that the spring k1 has to apply that exact same force back upon this point, because since this point is massless, it cannot have a non-zero net force because it would accelerate infinitely, because F equals ma. So what that tells us is that k1 delta x1, the force applied by spring 1, has to be equal to k2 delta x2, the force applied by spring 2. And in addition, this is the total force that the block experiences, except that we have to add a negative sign here. And the reason for that is that if the block is displaced a positive distance, x, to the right, then these springs will pull it back to the left. So that's going to be a negative force. On the other hand, if the displacement is negative, then the springs are going to exert a positive force upon the block. And so we have to add this negative sign in order to make everything work out. Now what we also know about these displacements is that the total displacement of the block, x, is equal to delta x1 plus delta x2. Because the springs have to compress the exact same distance that the block moves. So what that means is that we can rearrange this. We get delta x1 is equal to x minus delta x2. And then we can plug this into this equality up here to figure out what exactly f is. So this tells us minus k1x plus k1 delta x2 is equal to minus k2 delta x2. So what this tells us is that if we multiply this side by k1 over k2 and then add it to the left-hand side, we're going to end up getting these two terms to cancel out, and we'll be left with just minus k1x. So we're going to do that. All we have to do is multiply this. Remember that this is f. If we multiply f by k1 over k2 and add it to itself, so f times 1 plus k1 over k2 is equal to, this will cancel out with this, and we just get minus k1 times x. So now this, if you just do the algebra, this becomes k1 plus k2 over k2, so we can multiply that through. We get f, the total force on the block, is minus k1 k2 over k1 plus k2 times x. So this is the force acting upon the block as a function of the displacement. So this, as we know, is also equal to m times x double dot, just our normal F equals ma equation. And so then we can rearrange this to get our harmonic motion equation. We get x double dot equals, x double dot plus k1, k2 over m times k1 plus k2x equals 0. And as we know, we can then use this to find the period. The period ultimately is 2 pi times the square root of the inverse of this coefficient here, so m, times k1 plus k2 divided by k1 times k2. So this will be the period of motion of this block here when it's connected to two springs in series. Now in part B, we're asked something very similar. This time we have a block lying in this sort of box enclosure. It's connected to a spring of K1 on the left-hand side and a spring of K2 on the right-hand side. Both of the springs are connected to the walls so that they can brace themselves on the other side. Now, if this block is displaced a distance x, I'm going to define this direction to be positive. If this block is displaced a distance x, the force on it is going to be minus k1x, because this block will pull it to, back in the opposite direction, or this spring will. And then this block will push it back in the opposite direction. So minus k1x minus k2x. So then we can do exactly the same calculation we did down here. This is equal to mx double dot. And we get x double dot plus k1 plus k2 over m times x equals 0. And this tells us that the period of this system is going to be 2 pi times the square root of m over k1 plus k2. So these are the periods of these two block spring systems.